It's tricky language to respond to because there's no numbers. So I don't think, oh, minus a half or whatever, but it's noticed. Like I usually, like you see, like I put a circle around like a sign or draw an arrow to an equal sign or something like that. It all matters. If you crush every question, look at it this way. If you crush every question, I will put on PowerSchool, I'll say excellent understanding shown. Like you've got it perfect. Now, if you crush every question, but you don't put the equal signs, you forget the occasional negative sign stuff, that's not 100% anymore. Does that make sense? Yeah. So it matters. It's not taking off tons or anything. Sadie, did you find whatever one you wanted? Yeah. You're good? Okay. All right, so we're moving on to class. There were 2 days of no me, kind of. So, oh no, it was only one.
Just Monday.
Yeah, just Monday. But it was kind of 2 lessons. So there was maybe questions from page 43 and probably questions from page 46. If we get a lot of questions right now, if I write down 15 questions, I'm not going to do them all. I'll just do a couple and then I'll record the other ones after. So as of this moment, anything from page 43?
I think that, yeah, I wrote here. I'll have a lot, but because I was confused about like 11.
Give me a couple of the hard ones. Number 11 from 43?
Yeah, 11 and 12, I think.
Okay.
And also, I wrote down 20, 21, and 22. Because I wasn't sure what to do with the decimal. I mean, not the decimal, but
Okay, we'll have a look. Anything, might as well write them down now from 46? From the most recent one? 5? Yeah, go ahead, Aaliyah.
13 and 9.
You're not talking, right?
I said 13.
Okay, I just keep hearing voices from over there and I see you looking up at me. It's like, I don't know what's going on. 5, 13, and 9? That covered everybody yelling? Anybody else? Okay. 43, number 11. Page 43. Yeah, and then 12 would be similar idea, it's just a bigger question. So we have number 11, 2 root 5. Oh yeah, sorry. 2 root 5 minus 3 over root 2. Okay, so what I'm going to do is I'm going to multiply the top and the bottom by root 2 over root 2, because this, it doesn't change its value. It changes what it looks like, but not its value. Root 2 divided by root 2 is 1. So root 2 times 2 root 5 is 2 root 10 minus 3 root 2. That's the top half. Root 2 times each of these, this is what it gives us. What's in this root stays in the root. What's out stays out. Root of 2 times root of 2 is root of 4. Some of you on the test, you would do root of 2 times root of 2 equals 4, like with no root sign. And some silly mistakes like that. Silly geese. So this is 2 root 10 minus 3 root 2. And that can't be simplified over 2. And we're done. You could simplifies it here. As what?
And then everything else is the same.
Oh, so the answer is wrong.
Yeah.
Okay. Yeah, I hate it when especially when you're just figuring something out. It's like, oh, I think I got it. I think I got it. Oh, the answer key says that's purple and not the root of 5. Must be purple. Yeah, it's irritating. You could kind of simplify this a little bit further, but you don't need to. But I'll do it just so you can see. Like if there was a 2 in front of here or something that was divisible by 2, we would for sure simplify. But we can't. So if this is really calling you, you can do root of 10 minus 3 root 2 over 2. But this looks uglier. All right. So I'm not going to do 12. Is that okay? Because it's a lot like 11.
Well, because
You want me to do 12?
Yeah, I
Whoa, please. Okay. 5 root 8. I'm gonna do it fast though. Watch how fast this goes. 5 root 8 minus 2 root 3 all over root of 6. Yeah, that's crazy looking. So we're gonna multiply that by root of 6 over root of 6. Yeah, there's gonna be some simplifying here. So 5 root 48. That's a weird looking 5. 5 root 48 minus 2 root 18 over root 36. Okay, 48. What's that going to break down? That's 2 and 24. That's 4 and 12. I got this. There's another 2, so 2, 2, 2, 8. 8 times 8. That's not right. 2 to 2 is 4. What is it?
8 times 6.
8 what?
8 and 6.
8 root 6?
No, 8 times 6 is 48.
Oh, so you're not even giving me the answer. So now I got to do it again. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3. So take out those 2, 2, so it's 4, so it's 4 root 3, so it's 20 root 3. Is that right?
I think so.
And then this just a 3 comes out, so it's 6 root 2 over 6. Well, now we can simplify. So this is 10 root 3 minus root 3 root 2 over 3. Is that what the answer says?
Yeah.
If I know I just did this stuff in my head. If you want me to tell you how, I will. I'm just trying to speed up. From 20 to 10? Because the 20, the 6, and the 6, they're all even. So they're all divisible by 2. So we divided 2 out of everything. So 20 goes to 10, 6 goes to 3, 6 goes to 3. They're all cut in half. That's the way I think of it. Does that make sense or no?
Then do you technically have to put the 2 on the outside of the bracket?
No, because it all cancels. It's like if I have 20a over 30b, I can simplify that to 2 over 3 a over b. They canceled. So it's different than if like if I was just factoring out at the top. Yeah, but here they're canceling. When it cancels, it's gone. Are you okay with that, Evan?
Yeah.
Did I go too fast for any of it?
No.
Okay. I'm not trying to look at you. I realized I'm in a really odd body position like this. It feels like I'm totally lost all my patience in you. It's just my neck really hurts. This side is better. Hi, everyone. All right. Okay, 20, 21, 22. Can I skip 20 and do 21 and see how that fits? Say yes. Yes. Okay, good. So that's what I'm going to do anyway.
Please go to page 43.
I'm sorry. Yeah. So this is cube root of 2 over 4a squared b squared. What is this? 4a squared b squared. Oh, we just need to rationalize. Okay. So you cannot have a cube root, any denominator that's under the root sign. And so even though we have the root over the entire fraction, the bottom is still under the root sign. So we multiply it by cube root of 1 over 4a squared b squared. Nope, we don't do that. Because it's cube root, so it has to be twice this. It's kind of like me starting over. The question is cube root of 2 over 4a squared b squared. The first thing I'm going to do is what I should have done before, and I got thrown by the cube root, is I'm going to separate this a little bit. So it's cube root of 2 over the cube root of 4a squared b squared. So now I have the clear denominator, clear numerator. And now what I'm going to do is I am going to multiply the cube root of this stuff, but squared. 4a squared b squared, and then that whole thing is squared all over the cube root of 4a squared b squared, but that whole thing is squared because I need to be able to take it out of this root sign. So it needs to be a cubed number. That's why, like with the previous examples, like this root 6 over root 6, it's just a square root. So I just got to multiply it by itself. It's a cube root, so I got to do another step. The good news is, as messy as this looks, the bottom, it just, the root sign just fades away into oblivion. On the top though, you've got the cube root. 4 squared is 16, 2 times 16 is 32, a to the 4, b to the 4, all over 4a squared b squared. But now because it's cube roots, we might need to simplify this top a bit. 32, yeah, that's 2 times 2 is 4 times 2 is 8. So it's going to be 2 root 4, 2ab cube root 4ab all over 4a squared b squared. And then you simplify more. It becomes a 2, a's and the b's go, equals the final answer, cube root of 4ab over 2ab. Please tell me that's right. I don't think I screwed up.
Oh, yeah, that's right.
Did that make sense?
Wait, what is the, why is it 2 and then a 4? Or did I do that wrong?
Okay,
Under,
I'm hearing murmurs, you guys. I'm hearing lots of murmurs. And my main point is I'm hearing you, so don't let me skip over this. If you don't get it, don't sit in the shadows. Sorry, say again, please, Evan.
like under the denominator, there's a 2 and then there's a 4.
Here?
That, yeah, like right there, like why is there?
Because it was 2 over 4. What I just did is we had a fraction 2 over 4. 2 goes into 2 once. 2 goes into 4 twice. That's what I did. So this became 1 over 2. And I was just crossing it out and saying there's 2 left over.
Oh. So
I was just simplifying.
Could you have simplified at the beginning, like done 1 over 2a squared b squared? Since it was 2 over 4a squared b squared. Like right at the very beginning.
You can't, I think if I understand what you're saying, move this down for a sec or up, whatever. You have to do something on top as well as the bottom because you have to multiply it by 1. So I can't just do 1 over something.
Okay.
And if I did just do that 1, then it wouldn't have come out. You know what I mean? It would have stayed simple.
No, like
Like at the very beginning.
yeah, at the very beginning with the 2 like that, you simplify that into
Oh, could we have simplified this first?
yeah.
Yeah, probably should have.
1 over
Yeah, probably should have.
okay.
Why not? Yeah, totally. Sorry, I thought you meant instead of multiplying it by this, multiply it by 1 over.
No.
Yeah, no, you totally could have. Yep. Anybody else lost? I feel like some people are lying to me with their silence. I'm not trying to grief anybody here, but I can't help you if you don't tell me. Hi.
Hi, so you move the paper up, no, other way.
The other up?
You multiplied, you multiplied all that.
Yep.
And you multiplied the top 2 together.
Yep.
And how did you get 32 from that?
Because these things are squared because of the cube root. I've got this is squared and this is squared. So I just did 4 squared, that's 16. 16 times 2 is 32.
Oh,
Yeah. Anybody else? Do you need me to do 22? I can if you want.
I think I got it.
All right. If you change your mind,
Did you do 22?
are you being serious? Yeah, I'll do it. Only because you're serious, because we don't joke around in this room. 22. Holy crap, my neck hurts. 4th root, 1 over 8x cubed, 1 over 8x cubed. So it's the 4th root. Another way to write this is 4th root of 1 over 4th root of 8x cubed. So here's the thing. So what we could do, like if this was just a square root, like there's a bit of a thinker game here. If this is just a square root, then we just multiply it by the root of 8x cubed over the root of 8x cubed. But this is the fourth root. We need to be able to take all, like, whatever version of 8, whatever version of x out, so that we can have a rational fraction. To do that, we could, I'll do this in green. No, I'll do it in black, because green means go. We could multiply this by fourth root of 8x cubed, and then this is cubed itself, so that we have a true kind of fourth root. Even if you can't see that, just trust me what I'm saying, 8x cubed, but then it's to the third root, because then these together would be like 8 to the power 4, x to the power 4, it all balances. It gets out. But also, if you stop and think about it for a sec, 8 is 2 times 2, oh, I'm sorry, am I boring you? 2 times 2 times 2, that's 8. If we add another 2, so in other words, 2 to the power 4, that equals 16. The fourth root of 16 equals 2. I hope I'm not losing any of you. Some of you hopefully just clicked and you went, oh, so just multiply this by 2. I'm just going to do the fourth root of 2x, because that's going to bring this to 16x to the 4. I can take all of that out. I'll show you. It's a good thing I'm doing this question. So I'm simplifying this. That's just 1. I don't need all that other noise. 1 over fourth root of 8x cubed. This is what we have. That's what this is simplified to a degree. I'm going to multiply this by the fourth root of 2x over the fourth root of 2x. So on top, the fourth root of 2x times 1 is going to be fourth root of 2x. On the bottom, it's the fourth root of 16x to the 4. Well, this doesn't get simplified. It's just fourth root 2x. The bottom, the fourth root of 16 is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's 2, and then x to the 4, the fourth root of x to the 4 is x. Done. Now I could have, like I said, I could have done 8x, whatever this is, cubed, squared, and then do all that stuff, and it would all eventually cancel down and simplify to this. We'd have a bunch of numbers up in the root sign here. We'd have a bunch down here. Lots would cancel. Some would come out, they'd cancel, but we'd still wind up with this as our final step.
So you're simplifying it so it can be divisible by the fourth root,
Yeah,
so that it can come out
I'm-
easier?
I'm playing with the end in mind. Yeah,
Yeah.
I could totally have done this, and I still could if you want to see it. I don't want to do it, but it'll be messy. It'll take up the page. Are we kind of okay? Is anybody like, not anybody who's considering dropping right now, the people who are going to stay for sure, any of those people, are you like, I'm lost? Because I don't want you to be lost. Yeah?
I had a question.
Yeah.
So why do you have, so up there you just put 1 instead of is that the fourth root of 1?
Yeah, because it's just going to be 1. I just don't want to keep writing the
Okay,
root
so
sign.
you didn't like simplify it, you just like knew what it was gonna be
Mhm.
already.
Mhm.
I was, okay, yeah.
Like any 1 under any root sign, it's just 1.
Yeah, okay.
And even if it's an odd root, like a cube root or a fifth root or something, it can be a -1. Okay, so we're moving on to the second half of yesterday's work. Starting with number 5. Oh yeah, this is not a difference of squares. I looked at number 6, I saw number 6 is a difference of squares, and whoever wanted this may have been tricked. 5 root 2 plus 1. So it's basically, this question is 5 root 2 plus 1 squared, because it's just multiplying itself. 5 root 2 plus 1. Now, there are 2 positive signs. This is not a difference of squares. This is a sum of squares. So you have to do all the math, and you have to add it all up. 5 root 2 times 5 root 2 is 25 root 4. 5 root 2 times 1 is 5 root 2. 1 times 5 root 2, 5 root 2. 1 times 1, 1. Was that too fast for anybody? Is this big enough? Like, is it zoomed in enough? Jessica, you can see okay?
Yeah.
So now, the root of 4 is 2. 2 times 25 is 50. 5 root 2 and 5 root 2 is 10 root 2. 1 is just sitting there, so it's 51 plus 10 root 2. What's 51 divided by 3? 17. The root of 4 is 2.
Oh, okay.
2 times 25.
And why
That's it. Done.
in the 10 root 2, why does the 2 stay the same? When we check?
Because 5 root, this is a mistake some people were making on their test. It's the same as saying 5x plus 5x. It becomes 10x. It doesn't become 10x squared or anything like that, or 10 2x. It's like, it's this saying 5 apples, and 5 apples is 10 apples. Try and, as hard as it is, even though there's numbers in here, try and think of it that way. Which is different, like you can't say 5x plus 5xy. They're similar, but you cannot combine them. Same as if it's 5 root 2 plus 5 root 12. Those, you cannot combine those. You can't simplify those. Yeah. Okay, moving on. 13 and then 9. So actually, let's do 9 instead, because we want to do things in order in math. 1 plus root 2 times 1 minus root 2. These are nice and fun and easy. I wonder if this one had a back of the book wrong answer. 1 root 2, 1 minus root 2. So if I do all the steps, 1 times 1 is 1. 1 times negative root 2 is negative root 2. Root 2 times 1 is root 2. Root 2 times negative root 2 is negative root 4. So these two middle pieces cancel. Negative root 2, positive root 2, that's 0 root 2. So it's 1 minus 2, which equals negative 1. That's what?
That's what I got.
Good. Well, I said, that's dope. Yeah, okay. Who wanted this one? Are you okay with it?
Yeah, I would, instead of canceling them, I had like added them, so I had 2 root
Oh, okay.
2 instead. So I was like, why am I doing this?
Yeah, it's like I was saying before, it's like negative x plus x. As much as possible, trying to see these things that way.
I wasn't like changing the root number, but I was pretending there's like a 1 in front, and then I added them.
Oh, okay. And you can totally do that, but it's negative x and positive x. Negative 1x, positive 1x. All right, lastly, but not leastly, Jason Priestley, number 13. Oh, see, this looks like, some of you might see this and go, well, this looks like a difference of squares. It looks like it, but it's not. And so that can cause problems. 2 root 3 plus 1 times root 3 minus 1. See, if this was 2 root 3 minus 1, then you have a difference of squares. But here you don't. So when we're doing our first inside, outside, last, 2 root 3 times root 3 is 2 root 9. 2 root 3 times negative 1 is negative 2 root 3. 1 times root 3 is 1 root 3. I don't need that 1 there. And negative 1, 2 times 3 is 6. Minus root 3 minus 1 equals 5 minus root 3. I know I did that fast, but did I do it too fast? Who wanted this one? Is that okay?
Yeah, I realized what I did wrong.
Okay, good. That's all that matters. When I'm asking who wants it, I just want to make sure that your question's answered. Okay, that's it for questions. Do we even have time to learn? Heck yeah. I'll make this bigger.
Does that say rationalizing?
Yep. So when we talk about rationalizing, when we talk about rationalizing a fraction, what does that mean?
Making it into a rational fraction?
Yeah, and usually what does an irrational fraction look like?
It has a square root on the denominator.
Yeah. Yep. Good. I think I referenced conjugates. I feel like it was forever ago. It's probably because I was recording yesterday's lesson at 4 o'clock on Friday or something. But whenever it was that I was talking about conjugates, well, here it is. Because it's one thing, if we have 5 over root 5, that's our fraction. We want to rationalize that. That's easy. Root 5 over root 5. But if on the bottom, if our denominator is 2 plus root 5, I can't just multiply everything by root 5. It's not going to kill it. But it will if you use the conjugate. That's everything that is today. Are we all good?
No.
Okay. No rush. Stop fooling around and take the notes. Outside of that, you can rush. You guys out at lunch at all? Is it kind of warm? It's still raining? Okay, no, it's fine. I like talking to myself. It's good.
It's not raining.
It's good.
It's impossible to get behind.
Oh, I heard it's just a lake or something, hey?
I like had to step across like the concrete like parking things, and as I jump, I have like 8 pound
See, I
backpack,
slipped
like,
this morning.
balancing. No,
It was full of mud.
I felt so dumb. I was like falling against the portable thing.
I was biking this morning. I'm like, as I'm biking, I'm like, should I go around this puddle? There's cars coming. It's like, I'm just hitting every puddle on the way here. Are we good? Are you good, Ada?
Yeah.
Anybody still writing? All right, so examples page 49. You'll notice on the top, it says find each conjugate. So there's like, well, it's right there. But all you're doing is the exact same thing with a different sign. The root of 7 plus 1 becomes the root of 7 minus 1. 2 root 2 minus 3, well then the conjugate is 2 root 2 plus 3. 2 root 5 minus 3 root 3, it's gonna be, don't check, don't doubt me. 2 root 5 plus 3 root 3. Were you checking?
No, I was checking.
Okay.
Okay.
So we're not gonna do that. We're gonna rationalize and we're gonna do that work. No, Caleb, you mean, oh yeah. Yes. Can you feel it? Okay. Numero dos. Rationalize each denominator. I think part of the reason my neck hurts is marking the math tests on Friday. 2 over root 3 minus 1. Okay. 2 over root 3 minus 1. We are going to multiply this by root 3 plus 1 over root 3 plus 1. That is the conjugate of root 3 minus 1. So this right here, but be careful because every once in a while, like I know I'll get into autopilot and I'll do, like you might get some, well here, like this example here. It's 2 root 3 plus root 5 over root 3 minus root 5. So it's a little bit different. And I'll start kind of doing the conjugate at the top, conjugate at the bottom. That changes the question. You can't do that. So just pay attention. It's the same on top as it is on the bottom. It's the conjugate of the denominator. Then you multiply it through with fractions. Top, I guess left to right for you guys. Top times the top, bottom times the bottom. So in this case, it's 2 root 3 plus 2. That's on top. Good? And then you don't need to do all the steps because they're going to cancel, and these are good steps to skip. So root 3 times root 3, root 9. Let's just skip to the end. -1 times +1, -1. So it's 2 root 3 plus 2 over 3 minus 1 over 2. Now we can do some canceling. But I'm going to pause because I see people are writing and I don't want to lose you. What you could do, because there's a 2 as part of everything, I would be okay if you just cancel, like do a line through it, line through it, line through it, rewrite the answer. But I'll show you the steps just in case. So if I factor a 2 out of the top, it'll be root 3 plus 1 all over 2. 2 divided by 2, that's where it cancels. 2 divided by 2 is 1. So the final answer is root 3 plus 1.
Why did you put 2 outside of the bracket?
Because I'm just kind of showing if I'm finding a common factor. I took the 2 from 2 root 3 and the 2 from this 2, just so it's super clear that there's a 2 on top, a 2 on the bottom that we can take out. Because I know some people, it gets tricky if they start pulling them out of different ones. You know what I mean? If there's multiple things going on. If I have 12xy squared minus 24x squared y plus 2 all over 14 x, y, z or something like that. You can take a 2 out of every single thing here and then they cancel. And then you also got to look, how many x's can I take out of each and all this other stuff.
So you have to pull out the 2 from the
Every
numerator
single-
before, so you can't just have the numerator and then cross out all the 2's. You have to
You
first
can.
take out the 2 out of the numerator.
You can cross them out.
But
I'm
then
just,
when
I didn't
you-
want to lose you. I didn't want to lose you guys. That's why I showed the step. Normally I wouldn't show the step, but don't forget this 1.
Yeah.
People will cross out the 2 and go, okay, it's gone. No, because what you're doing is you're dividing by 2. 2 divided by 2 is 1. Now this is 1 root 3. 2 divided by 2 is 1. Now this is 1. This is over top of 1, which is the same as, you know, not. Yeah, it's that kind of hidden one. It's parts like this, like that part right there, that will catch people. Are we okay for the next example?
Which 2 did you use to take out that one? The bottom 2?
It's an interesting question. Which 2? I honestly don't think I know how to answer that. Like, it's
Like, will it always be the same number there?
same number where?
Like, you have the 2 on the bottom and the 2 on the top, and you have the third 2 on the other top.
Yeah.
Top. So then did you use the bottom 2 to take out?
Yes.
Okay.
I think I'm understanding you correctly. Yes. Like now, so here's the thing. If my bottom, if it was 2 root 3 plus 2 over 2 plus n, or who cares, whatever. There's no 2 here, we're done. We cannot simplify this any further. But if there's a multiple of 2 in front of this n, if it was 2n or 44n or something, then we can take a 2 out of everything.
So the whole numerator has to be the number that you're dividing the top by to simplify
I think so.
it.
There has to be, whatever it is you want to simplify and cancel, it has to be a part of every single term.
Yeah.
Because a binomial is 2 terms. This is a trinomial, it's 3 terms. I can't just take the 12 out and there's, if this is 12 here, I can't just go, oh yeah, 12, 12. No. That's a gong show. That doesn't work at all.
So if there was a factor of 2 and then you could do it.
Yep. If there's 2 here, now all the 2's get canceled. Yep. We'll have more like that, I'm sure. B. I was excited for my birthday tomorrow. 2 over root of 6 minus root of 3. So the conjugate is the root of 6 plus root of 3. So I see I just about put a 2 up here. I just about put a 2. You gotta watch yourself and don't be dumb like me. Root of 6 plus root of 3. I would never call you dumb though. Root of 6 plus root of 3. Call my son dumb. Probably too much. It's in a good way. It's loving. 2 root 6. Man, that sounds like, okay. I'm recording this conversation. I should not. I should just stop. Root 6 times root 6 is root 36. And I'm skipping the middle parts. Root 3 times root 3, negative root 9. Are you guys okay with me skipping the middle parts? You'll need to start to. Because we're the ones who decided this is the conjugate. So we have to have a certain amount of confidence that FOIL, the O and the I, that stuff's going to cancel each other. You would have positive root 18 and negative root 18. So they'd cancel. So anyways, we got 2 root 6. See, we still got some 2's here. 2 root 3 all over 6 minus 3 all over 3. Can we simplify this? Nothing we can do. It's done. It is too bad. Weren't you hoping for a 2 like me? It was not to be. I didn't mean to rhyme. Just did. Okay, one more example. Anytime I'm doing this and you're like, oh, this is too easy, just jump into the lesson. You don't have to wait for me, but just don't do it loudly because I'm still teaching here. 2 root 3 plus root 5. Okay, this is part C. 2 root 3 plus root 5. Yeah, this one's going to be messy. All over root 3 minus root 5. Root 3 minus root 5. Root 3 plus root 5. Root 3 plus root 5. Did I tell you about this time? Quick story. One of my first teaching jobs, I shook hands like at the board office. I'm going to be doing grade 9 math. Awesome. I love doing grade 9 math. I get there and they're like, nope, somebody else wanted it. You're doing grade 9 English. It's like, ugh, 3 classes of it. Ugh. So I was not an English teacher. It turned out okay. But this one, I was doing this spelling thing because I'm trying to get their vocabulary bigger and the spelling was terrible. So I'm doing spelling tests. I realize now, who does spelling tests grade 9? Oops. Do you guys have you? I don't want to knock any of the teachers here. Okay. Anyways, this before I was any good. So I'm reading words and I'd say something like beautiful. My wife is beautiful. Beautiful. And then somewhere in the class, I'd hear this. And I'm like looking and I'm trying to figure out who's saying I'm whipped, you know? And so I'll be like, intelligent. My wife is intelligent. And then I just hear this like, and I could not figure out where it was coming from. And I was focusing so hard, I accidentally started spelling the words. I was like, incredulous. INCR. And kids are just like writing it down. This one girl's like, no, Miss Morris. And they're like, shut up. I never did find out who that was. Okay. 2 root 3 times root 3 is 2 root 9. Oh, but notice on the top here, this is not difference of squares. So this is going to be a mess and I might not have enough room. 2 root 3 times root 3 is 2 root 9. 2 root 3 times root 5 is 2 root 3 times 5 is 15. Root 5 times root 3 is root 15. And then root 5 times root 5 is root 25. Okay, I got lucky. Can you guys even see that though? And then this is going to be root 9 minus root 25. And I will stop for a moment. Drink my grody weak Gatorade water. What just happened?
Yeah, I'm gonna drink the water.
Right? Oh, you guys. So on the top, okay, well, I'm going to stop recording because, oh no, you know what I can do? Oh, I can. Is it on the screen? Oh, mama. Okay. So now I'm going to rewrite this and I'm going to do some changes as I go. 2 root 9. The root of 9 is 3. 2 times 3, 6. Root of 15, that's 3 times 5. That doesn't get simpler. But 2 root 15 plus root 15 is 3 root 15. Root of 25, 5. on the simple, on the, I don't even know what I was gonna say, denominator. 3 minus 5 is gonna be -2 down here.
Can you have a negative on your denominator for the
Yeah,
final answer?
yeah.
Wait, why would it be? Oh, yes, I understand.
Here's the funny thing about negative signs. So this is my final answer, and that looks gross and weird and ugly, and it just is what it is. There's no more simplifying. 11 plus 3 root 15 over 2. Can't cancel, can't simplify.
Where did the negative go?
Yeah, I'm about to get there. So here's the thing, because you asked, well, is it okay to have a negative? If I put the negative down, I'm gonna write 3 negatives, just write 1. You can have it here, you can have it like in the middle, or you can have it up top. The tricky part is if you have it up top, it looks like it's -11 and positive 3 root 15, but if it's on top, everything is negative. My preference is I just say the whole thing is negative. But
So
yes,
the-
this is 150% okay.
If the negative was on the numerator, would you do the same thing?
Yep. Yep. Like it's easier if I just simplify, like negative x over y is negative x over y is also x over negative y. These are all the same, except you can't even see them.
But if the negative was on the second half of the
Okay, that's different.
equation on the numerator.
That's different. So
And then
11
you flip
minus
it.
3 root 15.
But then you flipped it to have -3 root 15 plus
Okay.
11.
Okay, hang on. I just want to make sure everybody's done copying this, and then I just want to move the paper. Is everybody done copying? Everybody's good? It is recorded. Not like that does you a lot of good in this moment. Okay, so if we have, I don't remember what it was, 11. Oh yeah, see, even in the textbook, they moved it to the middle of the fraction. So let's just say you have 11 minus 3 root 15 over -2.
Yeah.
Okay, so let's say,
Yeah.
okay, let's say you have this. You have to be careful. I would not put the negative up on top because it would look misleading. I would write it like this. So it's 11 minus 3 root 15 over 2. Or, because you know how I said if it's up there, it affects everything. So the other way you could write this is -11 plus 3 root 15 over 2.
Or could you write it, wait a minute. Could you go up for a minute? Could you write it like as 315, -315 plus 11, and then move the negative outside, which they would cancel out?
They wouldn't
So-
technically
you know
cancel
what I'm
out.
saying?
Yeah, I know what you're saying. If they canceled out here, that 11 becomes negative.
My original question was just if you have the question.
If it's leading
above
like that.
As like, could you go up for a minute? If you have 11 minus 3/15 over 2, would you be expecting us to flip whatever, without the negative sign? Would you expect us to flip it to be -3/15 plus 11
No.
and then take the negative out? Do you get what I'm saying?
Yep, and no, that's
Okay.
no. If there was, here's it, like if your final answer and you were like -11 minus 3 root 15 over -2, then it's like, okay, do something about that. Like this isn't wrong. This isn't wrong, but this also, this here equals 11 plus 3 root 15 over 2. That's just a better looking answer.
Yeah.
You know?
Yeah.
But it's not wrong.
Okay.
Bowels of negative signs. Now you know everything you've all never wanted to know about negatives. Are we good to go? You're good for your rock and roll? This is
Wait, just one more thing. So if I was like in a test or whatever and I forgot to just be able to like cancel out the negatives like that, I would just take out like -1, right? And then do the work and then simplify it and then cross out the negatives. Okay.
the way to go from here to here is multiplying this by -1 over -1. Yeah. Yeah. Changes all the signs. And this, you're not actually changing anything because -1 over -1 is 1. It doesn't change anything. So yeah. Okay, let's stop that recording. That's going to be a big file to upload.